In this video, we're going to do the first partial derivatives of the function u is equal to x to the y over z. That means we're going to do the first partial derivative of u with respect to x, then with respect to y, and finally with respect to z. First, we'll find u sub x, or the first partial derivative of u with respect to x. This one right here. Here we'll treat x as our variable, and we're gonna call our x as red in our equation, just to keep track which one among x, y, and z is the variable, and in this case x is the variable. And also we're gonna treat y and z as constants. Now, taking the derivative of this function, we have u sub x. Note that we write x as our subscript here since we're differentiating with respect to x. Then u sub x equals y over z right here. Take note also that we'd move y over z down here since that's our constant, times x to the new exponent, and we'll subtract 1 from the exponent y over z, and we'll have y over z minus 1, and according to the derivative rules. Then we have the first partial derivative of u with respect to x is equal to y over z, x to the y minus z all over z. Next, we'll find the first partial derivative of u with respect to y. We'll treat y in this case as a variable, that's y. Again, we're going to color y red in our equation and treat x and z as constants. Again, we'll treat y as a variable, and here we'll have to apply natural logarithms to both sides of the equation just to separate x and z from y. Then we'll have ln of u is equal to ln of x to the y over z. And according to one of the properties of logarithms, you can move the y over z right here, and we'll leave x alone with the ln. Then we'll have to get the derivatives in both sides. The derivative of ln u with respect to y then is 1 over u times the partial derivative of u with respect to y equals the derivative of the right side, which is the product of the constant ln of x over z times the derivative of the variable y. We write it down right here, derivative of y, but the derivative of y, take note, is just equal to 1 since we're differentiating with respect to y. Then the equation becomes 1 over u times u sub y is equal to ln of x over z times the differential of y is 1. Then after that, we'll have to multiply u to both sides to cancel u out. Then what remains in the left side of the equation is u sub y, and that equals to u ln of x over z. But u is just equal to x to the y over z, that's why we're going to substitute that to our equation. U sub y is equal to x to the y over z times ln of x all over z. Then that's our first partial derivative with respect to y. Lastly, we're going to work on the partial derivative of u with respect to z. Again, we're going to color red the variables so as not to confuse others to be the variables. Let's treat z as variable and x and y as constants. The same case with finding the partial derivative of u with respect to y. We'll have to apply natural logarithm or ln to both sides of the equation. We have ln of u equals ln of x to the y over z, and we're going to bring the y over z down here times ln of x. Then we'll have to get the derivatives of each side. The derivative of ln of u is 1 over u times u sub z again. Subscript the z since we're differentiating with respect to z. That equals the y ln x times the derivative of z to the negative 1, since 1 over z is just equal to z to the negative 1. And that equals to y ln x times the derivative of z to negative 1. We have to move negative 1 down and subtract 1 from negative 1. We have negative z to the negative 2. Then u sub z is equal to u times y ln of x. Since we multiplied u to both sides of the equation, that's why u cancels out. That's all over this one's negative right here, all over z squared. And since the value of u is equal to x to the y over z, that's why we're going to substitute that to our equation. Then this is it. This is the partial derivative of u with respect to z.